Hi, today we're going to talk about linear functions. First, we got to talk about the linear parent function. A parent function is the most basic, the simplest form of a whole family, a whole type of functions. So for linear functions, that is y equals x. And notice we're not going to add 2 or subtract 3 or divide by 9 or any of that. It's just y equals x. It is as simple as we can get. Well, it'd be nice to see what that looks like on a graph. So I'm going to do my best. Draw a nice straight line there. Okay, that's my best version I can do of y equals x. So notice it goes through the origin, 0, 0. Other points on this line would be 1, 1, 2, 2, 3, 3, so on. And then going down, we'd have -1, -1, -2, -2, -3, -3, and so on. Well, it'd be really helpful to know what the domain and range of this function is. So D for domain, R for range. And remember our friend Dixie Royd. So Dixie are the values of x. So ask yourself, what's the smallest value of x we can have on this line? Well, going to the left, it goes on forever and ever. Okay, what's our largest value? Well, we have the same thing going on. Going on to the right, it goes on forever and ever. So that means any number is in the domain of y equals x. So that means the fancy way of writing this is x is in the set of all real numbers. So that's what this symbol right here means. That means in the set of. And if you look at this R, you can kind of see that A for all and the R for real numbers. So x is in the set of all real numbers. Well, let's look at the range. So again, thinking about Dixie Royd, range is our y's values. Well, the smallest y value, we don't have one. It goes on forever and ever. And same thing with the biggest y value. We don't have one because it goes on forever and ever going up. So that means our range is that y is also in the set of all real numbers. Okay, let's talk about the different representations we can have of a linear function. So first we have the equation. Well, our x can be to the first power. That's the only exponent we can see. And keep in mind that when we have something to the first power, we usually don't bother writing that 1. We would just write x. But I like to write that to let you know that there can be no other exponent. So if there's a 2 here, if there's a 3, if there's a -4, that's not a linear function. Same thing with y. Y's got to be to the first power. And again, normally we just write y by ourselves and leave it at that. Also, you cannot have x in the denominator. So that means no 1 over x. That's a completely different family of functions. No 3 over x. No 3 over x squared. None of that. X cannot be in the bottom part of a function. So what I'm saying is, don't do this. Don't want that. That is not a linear function. Okay, graphically, there are 3 different graphs we could have. So it could be, first of all, it could be increasing. So here's an increasing linear function. It could be decreasing. Here's an example of a decreasing linear function. So let's label those. We could have increasing. We could have decreasing. Well, you should be asking yourself, well, that describes most functions. We forgot about constant. So if we have a horizontal line, that is constant. It's not increasing, it's not decreasing. So I bet a few of you are asking me, well, Mrs. Stratman, what about vertical lines? Well, here's the problem. Vertical lines are never functions because they would fail the vertical line test. So we can have a horizontal line, that's a linear function, but we cannot have a vertical line. Vertical lines are not functions, ever. Alright, moving on. Okay, our third representation for a linear function is a table. So we would like to put our x's on the left and our y's on the right. So let's do an example. Let's say our x's are 1, 2, 3, 4. Let's say our y's are 3, 5, 7, 9. And yes, that's the 3 hiding under my y. So here's what's important. What's the difference between 3 and 5? Well, that's 2. So we went up 2. 5 to 7, again, we went up 2. 7 to 9, again, we went up 2. So notice, this is constant. It's the same. So if the space between doesn't change, that is probably a linear function. Alright, a little reminder. Your domain, which we talked about up there, think of it, if you can't remember of Dixie Royd, domain is left to right. Look at where it stops or stops or begins on the left, where it stops or ends on the right. And our range is lowest to highest, or up and down. Okay, we're going to do 2 practice finding domain and range of a linear function that's actually just a line segment or array. So hopefully you can see this. I think you can. So this line segment starts at 1, 2, and it ends at 3, 4. So this might help me. My lowest domain number, so looking at domain, we're looking at x's, so we're going to go from 1 up to 3, but not including 3. And here's how we're going to write this. So 1's our smallest number in the domain, and it's going to be less than or equal to x. So remember our number line, if it's less than or equal to, you have a dot, but if it's not equal to, we had an open dot, right? So that x has got to be less than 3. So notice our domain, all our x's have to be less than or equal to 1, it can be equal to 1, but it's got to be less than 3, it cannot be equal to 3 because we have an open dot. Range, we're going to do same idea. So our range, let's look. Our smallest number on the range is a 2, so I'm going to make a little note, 2. And our biggest number is a 4. Alright, so that means 2, and since it's a closed dot, we want less than or equal to y, because range is y. And that's going to be less than 4, because again, we have an open circle, so it cannot be equal to. Alright, it's going to be a little different with array. We'll see what I mean. Alright, so let's look at our x's. So looking at our domain. Well, the smallest number is 2. But our biggest number, it goes on and on forever and ever. So we don't have a biggest number. So what we're really going to say is x has to be greater than or equal to 2. And that's it. For the range, well, this is kind of weird. It starts, the lowest number is somewhere way down here. It doesn't have a lowest number, but it does have a biggest number. The biggest number is 3. So we're going to say that y has to be less than or equal to 3. Because we're not going up, we're going down. So here's a nice way of thinking of it, is if you have 1 dot, you're going to have 1 inequality sign. If you have 2 dots, you need 2 inequality signs. That's the way I like to think of it. Alright, if you have questions, let me know.